Hello and welcome. In this video we want to do some questions using intermediate value theorem or IVT. The first question is this: prove that the following equations have at least one solution, one real solution. Before we start this question, let me remind you briefly the intermediate value theorem and how we use it to answer these type of questions. First, you have to define a function f of x. And attention, that function f of x that you define to solve the question should be a continuous function. Then you have to find two numbers like a and b that the function f at those numbers is positive and negative. So at one of those numbers that you are finding or you are guessing, the function f should be positive and the other one negative. Then, because the function is positive, let's say at point A, and negative at point B, then definitely, based on the intermediate value theorem, somewhere it crosses x-axis, and this means that the equation has a solution. There is a solution, there is a real solution for the equation. So after you find a and b, then you can use IVT to claim that the equation has a solution. And this completes the solution of the question. For this particular question, first, you have to define f of x. How we define the function f of x? We move all the terms of the equation to one side and then we name it f of x. Here the equation is x plus tangent inverse of x equal 1. First, move this 1 from the right to the left like this: x plus tangent inverse or arctan x minus 1 equal to 0. So move everything to one side. Always the format of the equation should be like this. Then we name this f of x. So f of x would be x plus tan inverse of x minus 1. After you define f of x, you have to check the continuity of f of x, because this is the condition that you need for using IVT. Obviously, this function is continuous. X plus tangent inverse of x minus 1 is a continuous function. X is a continuous function. Tangent inverse of x is continuous on all real numbers. And minus 1 is a constant function, so it is continuous. So you need to mention that you consider this condition. F of x is continuous. Now you have to find two numbers that one of those numbers make f of x positive and the other one makes f of x negative. And it's usually not too hard to find those numbers. For example, here I start with 0 as the first number. If I plug in simply 0 here in this equation, f of 0 would be what? 0 plus tangent inverse of 0 minus 1. Usually it's a good number to try as the first number. 0 is a good number to try it always. What is tangent inverse of 0? If you remember from trigonometry, tangent of 0 is 0. So because the tangent inverse is the inverse of this function, so that the tangent inverse of 0 is also 0. You need to know this to calculate this expression. If you don't know, you can use a calculator to calculate this expression. So this is 0. Tangent inverse of 0 is also 0. Minus 1 would be minus 1. So f of 0 from here we can say is less than 0. Now we have to look for a number as b to make the function positive, actually as a, because we find a number that make the function negative. Now we have to find another number that makes the function positive. For example, let's try 1 as the first guess to see what happens. If it doesn't work, we can try other numbers. If we plug in 1, then we have 1 plus tangent inverse of 1 minus 1. 1 minus 1, they cancel each other. Only tangent inverse of 1 remains. Even if you don't know what is tangent inverse of 1, probably you know that the tangent inverse of 1 is positive. So this would be greater than 0. But if you wonder what is tangent inverse of 1, tangent inverse of 1 is simply pi over 4. Why? Because if you remember from trigonometry, tangent of pi over 4, tangent of 45 degree is 1. So tangent inverse of 1 is pi over 4. Now that we have found two numbers, that one of them makes the function positive, the other one makes the function negative, from intermediate value theorem, we can claim that, so based on IVT, there is a number c, there is at least a number c between 0 and 1. Why between 0 and 1? Because the numbers that we choose here is 0, 1. 0 and 1. Maybe you choose other numbers, so then c would be between those numbers. But in my solution, I choose 0 and 1, so the c is between 0 and 1. So there is a number c between 0 and 1 that makes the function, makes f equal to 0. And this is based on the intermediate value theorem. Now that we did this question, let's try the next question. Here we have this equation. 10e to the power of negative x over 10 is equal to 0.1 x to the 2. Similar to the previous question, first you have to define a function f of x. And to do so, first move every term in the equation to one side and set it equal to 0. So the first thing that we have to do is to rewrite the equation in this format. Minus 0.1 x to the 2 equal to 0. Then we define f of x like this. 10e to the negative x over 10 minus 0.1 x2. Again, you have to consider and you have to know that this function is continuous, and so we can use IVT for that. Now is the time to choose numbers for x, that one of them makes f of x positive, the other one negative. Similar to the previous question, I am going to choose 0 as my first number, because 0 is usually easy number to substitute in an equation or function to find its value. If we plug in 0 for x, then we have 10e to the power of 0 over 10. If we plug in 0, here would be 0. 10e to the 0 minus 0.1 times 0 to the 2. All of this is 0. So basically only we have 0 here. E to the power of 0 is 1. 10 times 1 is 10. So this is positive. Now we have to look for a number for x that makes f of x negative. Maybe it's a little tricky to find that number in this particular question. what we have to choose for x. If you have a calculator, obviously you can try different numbers, and finally you can guess and you can find the number that makes the function negative. For example, if we want to try something like 1, because if we plug in 1, we don't know what is e to the power of negative 1 over 10. If we plug in 1, this here would be e to the negative 1 over 10. And because without a calculator, finding the value of that is almost hard, it's not a good idea to try a number like 1. What number do you think is good to substitute in f that we can calculate the value of the function without a calculator? You need a number that when you substitute for x here, for x, you don't need any calculator. 10 is a good choice, because if you plug in 10 for x, 10 in the power and 10 in the denominator, they cancel each other. So I'm going to use 10. If we plug in 10 for x, the function would be 10 e to the power of negative 10 over 10 would be negative 1 minus 0.1 times 10 to the 2. This would be equal to 10 again times e to the negative 1. 10 to the power of 2 is 100. 100 times 0.1 is 10. I prefer to rewrite this as 10 over e minus 10. Because e to the negative 1 is reciprocal of e, or 1 over e, so we can rewrite it this way. Now without the calculator, simply you can see that why 10 over e minus 10 is negative. Because attention, e is 2.7 approximately. If we divide 10 by 2.7, it would be smaller than 10. So if we subtract 10 from that, it would be negative. So now we have two numbers that at one of those numbers f is positive, at the other one negative. So from IVT we can claim that the equation, this equation here, has a solution. Or actually we can claim that f of x is equal to 0 somewhere between 0 and 10. But you have to write it this way. So now we say from IVT, from intermediate value theorem, there is a number c, there is a number c between 0 and 10, such that f of c would be equal to 0. And this means that the function somewhere crosses x-axis, or in other words, the equation has a real solution. Now look at this question. Here we want to prove that the following equation has at least two real solutions. Usually, with the aim of intermediate value theorem, we prove equation has at least one real solution, but this is a bit unusual question. We want to prove the equation has at least two real solutions. Let's see what is the equation. The given equation is this: x to the 2 equals x sine x plus cosine x. For a moment, forget this question and focus here. We want to use intermediate value theorem to prove that the equation has two real solutions. How we can do that? With the IVT, normally we choose one number like a that makes the function negative, another number like b here that makes the function positive, and so the equation has at least one real solution. But attention, if you can find a third point like here that makes again the function negative, then we have one solution in this interval, another solution in this interval, then we can prove in this way that the equation has two real solutions. So the idea here would be to find three numbers, not just a and b, a, b, and a third point, that at one of those points, for example, the function is positive and at the other two negative, or the opposite. Maybe the situation is like this. At one point the function is negative, at two other points the function is positive, and if the function is continuous, then it has two solutions, as you can see here. This is the idea that we want to use to answer this question. So instead of choosing two numbers, you have to choose three numbers. But you have to choose those numbers in a special way. First of all, we are going to bring everything to one side and we are going to name it f of x. So x to the 2 minus x sine x minus cos x equal to 0. We moved everything one side. And we are going to name it f of x. F of x would be x2 minus x sine x minus cosine x. This is our function. Now we look for three numbers which at the middle number the function is maybe positive, at the left one and the right one negative, or at the middle one negative, at the left one and the right one positive. Because again, similar to the previous questions, the easiest point to substitute in a function usually is 0. I'm going to start with 0. So let's see what is f of 0. If you plug in 0 for x, this would be 0 to the 2 minus 0 sine of 0 minus cosine of 0. 0 to the 2 is 0. 0 times sine of 0 is 0. Cosine of 0, if you remember from trigonometry, is 1, but we have a negative here, so negative 1. So the value of the function at 0 is negative 1, and it is less than 0. So basically we have this situation. At 0, the function is negative. Now if we can find a point somewhere here that makes the function positive, and a point here that makes the function positive, then if you imagine a function that passes through these 3 points, then definitely it has two solutions. So now you have to choose 2 points, one greater than 0 and one less than 0, that makes the function positive. If we can find those points, we have answered almost the question. Maybe you think to number 1 or 2. Yes, you can use those numbers, but you will face one problem. If you want to plug in 1 in this expression, what is cosine of 1 or sine of 1? You don't know, probably. And if you want to find the value of the function at 1, you need a calculator. But we want to answer these type of questions without a calculator. So if you want to choose a number, choose numbers that you can find the value of sine and cosine. For example, think to numbers like pi, pi over 2, pi over 4, things like that. My point, in the left side of 0 is negative pi, and in the right side of 0 I'm going to choose pi. F of negative pi would be negative pi to the 2 minus negative pi sine of negative pi minus cosine of negative pi. Negative pi to the 2 is pi to the 2. Sine of pi and sine of negative pi, both of them are 0. So this is 0. Cosine of pi and cosine of negative pi are negative 1. Negative of negative 1 would be plus 1. So this is a positive expression. And this is clear that it is positive. What about f of pi? it would be similar, pi to the 2 minus pi sine pi minus cosine pi, and it equals pi to the 2 plus 1. It is also positive. Now look at this. We have a function that at point 0 it is negative. At pi it is a positive. It has a positive, and at negative pi is also has a positive value. If you imagine any continuous function that passes through these points, it's obvious that definitely this function should cross x-axis at least 2 points. One in this interval and one in this interval. So we can conclude from intermediate value theorem that f of x is equal to 0 at least at 2 different points. So how we can write this? We are going to use intermediate value theorem once for these 2 points, negative pi and 0. So we say from intermediate value theorem there is a number like c1 between negative pi and 0. There is a number c1. I named it c1 because there is another c1 between negative pi and 0, such that f of c1 equals 0. And again, from intermediate value theorem, there is a number c2 between 0 and pi. Attention, at 0 the function is negative, at pi the function is positive. So somewhere between 0 and pi the function is 0. From intermediate value theorem there is a number c2 between 0 and pi, such that f of c2 is equal to 0. So we prove that there is 2 numbers that the function is equal to 0. So in this way we prove that the equation has at least 2 real solutions. I hope you like this video. If you like this video, please subscribe in my channel and see you in the next videos.